What is up, guys? Fahir here from AwesomeTuts.com. And now that we have our snail moving left and right, what is the next thing to do? Well, the next thing to do is the following. Let me first take the ground that the snail is on and move the snail down like this. What we want is that when we hit the snail with our player, when we jump on it and hit it here, so from the top, we want the snail to go in the stunned mode. That is this one right here. So let me select the snail and it's stunned mode. This right here, it will go like this, indicating that, well, it is hurt, and then we can kill it. And we can kill it when it's stunned, then we can, well, hit it from the left or from the right, and it will push it in that direction. If, however, the snail touches the player on its left or on its right side like this, while the snail is not in the stunned mode, then it will kill the player. How can we do that? Well, the natural thing to do is go right here in the snail script and do something like void on collision enter 2D, which takes a collision 2D as target parameter, and then we can use the tag to detect if we are colliding with the player. By the way, select the player right here, so select him and then go in the tag and select the player tag and hit apply so that change applies to the prefab. So if we go here and we can type something like if target dot game object and the tag is equal to the player tag like this, we can, well, stun our snail. We can say something like anim play the stunned animation. Now notice here I'm using play and passing the name of the animation, which will make the animator play the animation with this name. If we go here in Unity, select the snail, go into the animator tab, you see stunned is the actual name of the animation. If you're not sure, copy the name and paste it right here like this. So now it will work. If we go here in Unity and run the game now, notice the snail is moving. Where is the snail? Here it is. If I jump on it, bam, it is stunned. But we have a problem here. The snail is still moving. We can fix that. The other problem that we have is even if we touch the snail on the side, you see, bam, we have touched it on the side, it goes to the stunned mode. Now, in order to detect collisions with a collider on the sides, it is a little hard. You need to do some calculations. You need to do this. You need to do that. For that, we can simply use ray casting. So forget all about this right here. We are not going to use it. Instead, as I said, we're going to use ray casting. So right click on the snail like this, right click on it and create an empty game object. Let me just move it above the bottom collision and duplicate it 2 more times and move this duplicated once also above the bottom one, because this one is going to be the left collision. So this is going to be the left collision like this. Did I spell collision correctly? I think I did. And I'm going to set the value or the position of this left collision to be negative 1.53. This is for the Y, or actually for the X. And for the Y, it's going to be negative 0.5. For the right collision, so right collision like this, the X is going to be the positive 1.53, so 1.53, and the Y is going to be negative 0.5. And for the top collision, we are simply going to set it, let me select here, and I'm going to rename it to top collision. And this one is going to be at, let's say 1.08 for the Y-axis. We're not going to move it, or we're not going to do anything on the x-axis for the top collision. So we have the left collision, we have the right collision, we have the top collision. And this is easier to detect if our player has touched our snail from the left or from the right or from the top. So now we need to go in our mono-develop in the snail script. Right here below our private bool move left, we need to add more variables. So we need to add a private bool can move to indicate if we can move or not. And also we need to add a private bool stunned. This is going to determine if we are stunned or not. And here we are going to have a public transform. We have down collision. We're also going to have left collision. So left collision, comma. We're also going to have right underscore collision, comma. So collision like this. We're going to have top underscore collision like this, and comma, we're gonna have down collision. Well, what is all of this here, and why am I writing comma? Now, this right here is a shortcut for typing. So here we will have left collision like this. Then we will need to do something like public transform right underscore collision. Then we do the same thing for the top and for the bottom, but instead of doing that, we can simply write that all in a single line by naming these variables and then comma, naming another variable, comma, naming another variable. This means we have 1, 2, 3, 4, 5, or actually 4 transform variables. So we have left, right, top, and down. It's a shortcut for writing all of what I just shown. Instead of writing public transform left, public transform right, public transform top, we can simply put them all in a single line like this. Now we are also going to have a private vector 3. These are going to be left collision position like this, and comma right, so right underscore collision underscore position. I will talk about what is this in a moment, but then, or now, we need to do the following. We need to go in Unity, select the snail, and attach these game objects. So left collision is going to be here, right collision is going to be here, and top collision is going to be right here. So drag and drop these to attach them at the appropriate spots. So left collision, right, top. Make sure that you have attached the correct ones, so correct collisions or game objects at the correct spaces, or otherwise you will have problems. So going back here, inside of the awake function, we are going to do the following. We are going to say left collision position is equal to left collision dot position, and right collision, so right like this. How did I write it here? So it's right, and here it also needs to be, let me just type it correctly, right like this. So right collision underscore position is equal to right collision dot position. Why are we doing it like this? Remember that our snail is moving left and right, and the left collision, you see, left collision is here. But when our snail changes the scale, you see, we change the scale. Notice now the left collision is right here at this position. But in our game world, if the player touches the snail from this side, this is the right side of the snail. But we have the left collision detector on that side, which means when we change the direction, we also need to swap the positions of the left and the right collision so that our code works properly. So do you get me now? The left collision is right here. So now when our player touches the snail from this side, it is touching it from the left side, which is okay. But when the snail changes the direction, notice our left collision is now here on the right side. So if we touch the snail from the left side, we're actually now touching the right collision, which can mess up our code. So we need to swap their positions when we swap the direction. We will do that in a second. So we have stored the left collision position and the right collision position. In our start, we are also going to say can move is equal to true to indicate that we can move. And all of these if-else statements, or I'm saying all of these like there are 20, but this if-else statement, we're going to put it here. If can move, so if we can move, then we are going to move to the left or to the right. Because when we are stunned, we are not going to move neither to the left, neither to the right. We are going to stand still in one spot. Now, in regards to changing our positions of these collisions, we need to go right here in the scale. So here, when we change to the left scale, what we need to do is we need to say left collision. So left collision dot position is now equal to left collision position. And our right, so it's right collision dot position is equal to right collision position. And in the else statement, when we change the scale to negative, we need to say left collision dot position is equal to the right collision position, and our right collision dot position is equal to the left collision position. Now don't be confused. What am I doing here? You see, In the awake function, we have stored the positions. So our left collision position is equal to the left collision, which is this one right here, and its position. Right collision position is equal to, and let me just make this more clear. I'm going to rename it like this. So it's going to be POS. Left collision POS, and here also. So I'm going to say here, left collision POS, right collision POS, and here I'm going to do the same thing. Right collision POS, right collision POS, and here also. Just so that you don't get confused by the names. What am I doing here? Left collision POS is equal to the left collision position, which is storing the current left collision position. And here we are also storing the current right collision position right here. When we change the scale, so here move left, we are moving to the left side, which means the left collision has the left position. Right collision has the right position, which is okay, which is the current start. You see here, currently left collision is at the appropriate position, left one, and right collision is at the right position. But when we change it to the negative and now we are facing the right side, the left collision needs to be at the right collision position, and the right collision position needs to be at the left collision position, so that this time it will work correctly. So we are simply swapping their positions. This is what we are doing, simply changing the positions. And I've explained that here again with the snail. Notice now, when I select the left collision, you see it's right here. And let me tag it. So left collision, you see it's here on the left side, but when I change the scale to the negative, you see now the left collision is on the right side. So we need to swap positions in order for that to work out in our code. So going back here in our check collision, this is where the magic happens. This is where we are going to check everything. So what we're going to do, we are going to take here arraycast hit 2D, which I'm going to call left hit, is equal to physics2D dot raycasts, and we're gonna raycast from left collision position or left collision dot position to which direction? Vector 2. So vector 2 dot left, and the length of the distance of the ray is going to be 0.1. Now we also need to create one more variable right here. I'm going to call it public layer mask player layer. So player layer. Going back here, we're going to say or search for the collisions with the player layer. Let's go in Unity. Select our player. So select the player. And for the layer right here, we need to create a new layer. Add layer, player, layer player. You see now I'm a rapper. Okay, layer player, layer player. I am going to select here player for the layer. No, this object only. So change only the object. We don't want to change the children's layers, and hit apply. So now we are checking for the raycast with game objects that are on this layer, which is the player's layer. We do need to select our snail and set that right here. So the layer needs to be player again. So go here in the drop down list, select the player layer. So it will, let me just go back here, select the player layer, and it will detect collisions only with game objects that are on that layer. The next thing that we need to do is we need to call or create a new raycast hit 2D. Right hit is equal to physics2D raycast from the right collision dot position in the vector 2 right direction using 0.1f and player layer. So this is what we are doing. We are raycasting again, and we explain what is a raycast. And now we will detect if we touch our player from the left or from the right. In regards to the top, we are going to use something called a collider 2D, which we are going to call top hit, which is going to be equal to physics 2D dot overlap circle. Now what is this? Well, first we're going to overlap it at the top collision position. The radius of the circle is going to be 0.2f, and we are going to search for the player layer. What is this overlap circle? Overlap circle is same thing as raycast, except we are overlapping a circle. So if our snail if our snail is right here and the top position is right here, we are going to overlap a circle with this line of code with the radius of 2. So let's say this is the radius of 2 and this is that circle. That circle will be drawn with the physics raycast. That's also a raycast, but it's a circle raycast. This raycast is a line like this, but this overlap circle is a circle. And it will detect anything that touches that circle, be that here, 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 it does not matter where. Same principle as this one right here, except that this is a circle. So it will detect collisions at this position. This is the radius of the circle, or how large that circle is. And this is the layer game objects need to be set on in order for us to detect collision, well, with those game objects. So what do we need to do now? Well, here we are going to test if our top hit is not equal to null. So we actually collided with a game object. We detected collision. What we're going to do? Next, we're going to test if our top hit dot game object dot tag is equal to the player tag. So if it's equal to the player tag, then what we are going to do? We are going to test if our game object is not stunned. So if it's not stunned, then we're going to stun our game object. So we're going to call here if not stunned. And if all of this is true, so if the top hit actually detects collision, if the game object that we have collided has the player tag, and if we are not stunned, we're going to do what? First, we are going to bounce off the player from that snail. Bounce it off a little bit in the, well, in the air. So we're going to call our top hit dot game object get component rigid body 2D, and we're going to say here dot velocity is going to be equal to new vector 2, and we're going to pass here top hit dot get component, or actually game object dot get component rigid body 2D, and we're going to say dot x. This is for the x velocity, and for the y velocity, let's say 7. This is simply going to bounce off, so rigid body dot velocity dot x. This is okay now. We are doing this because we don't want to change the velocity or the current velocity of the player. If the player is moving, his velocity x will be the same, but the y velocity right here, we are going to bounce him in the sky a little bit. And next thing that we're going to do, we're going to say can move is now equal to false, because our snail now is stunned. It cannot move while it is in the stunned mode. My body dot velocity, which is the velocity of the snail, is going to be equal to new vector 2, 0 for the x, 0 for the y, which means the snail will stop. So we don't move, and then we're going to stop moving. Then we're going to call our anim to play the stunned animation. And we're going to say here stunned is equal to true. And the last thing that we are going to do, or this will come later on when we actually create our beetle, because we're going to use also this same script for the beetle. So beetle code here. Don't worry about that. We will code that later on. Now, what is going on here? Let us test it out and see. Then it will be easier for me to explain. So let me take the player, move him right here. Notice now what's going to happen when we, well, jump on the snail. Bam, we jumped on the snail. You see, snail now is in the stun mode. It is stunned. It's not moving. It's standing still. You see, what happened? The following happened. We raycasted or overlapped a circle at this position, which is right here at the top. Let me just select it. Here it is. At this position, we overlap the circle so that we can detect when that circle collides with a game object that is on this layer, which is the player. If we actually collide with a game object, this right here detects collision, it will return something. It will return a collider 2D, and we will store it in this game object. Next thing is, if that game object is not null, if this object right here actually is not null, that means we have a collision. If the game object we have collided with has a tag player, so if he has a tag of player, and we are not stunned, then throw the player a little bit in the sky. Did you notice that? Notice now, when we collide, it will throw the player a little bit in the sky. See, bam, it throw them a little bit in the sky. If I go jump on the snail again, you see, I have jumped on the snail again. Nothing is happening because, well, we are not detecting collision because now we are stunned. we are using here, if we are not stunned, notice the exclamation mark, it will make what's after it the opposite. So if stunned is true, it will make it false. And here we're setting it to be equal to true. And then the next thing that we need to do, you saw that we have trouble. So if we land again on the snail, or if we touch it on the sides, we are pushing it left and right. You saw what I mean. We need to fix that. We need to fix that by detecting collision on the left and on the right. So what we are going to do next is that we are going to test if our left hit. So if we have a left hit, if this game object right here is not equal to null, then we are going to test if our left hit dot collider dot game object dot tag is equal to the player tag. So player tag like this. Now, one thing that I also want to show you, if you're using these tags a lot, so for example, here we're using player and here player, it can happen that we make a mistake. So for example, here we type, instead of player, we type player. You see, this will not work. What can we do? A good idea is to do the following: to go here in our project, and in the scripts folder, right click, create a new folder for helper scripts. And here I'm gonna create a new C# script, which I'm gonna call my tags. So my tags. In this script, I'm gonna store the tags for our game objects. So first tag that we have is gonna be a public static player, or actually string. So public static string player underscore tag, which is equal to player, like this. What is the benefit of doing it like this? Well, now I can go here, and instead of using player, I can simply say my tags dot player tag. And also here I can do the same thing, my tags dot player tag. What is the benefit? The benefit is that we are not hard coding player here, so we are not saying player, which can lead to errors. We can say player, and here we can say player, and we can remove something, and then we have a problem. We need to debug all of that. And now imagine if we have that on 20 places or 30 places, and we make a mistake on 10 places. Imagine how that debugging will go. But like this, we are using it on a single place. So here it is, my player tag. We're setting it to be static. We talked about static variables in the C# section. So that means that we can call the class and class name, so class name dot variable name, to call that variable. Which means if we have a problem now, we only need to go here and fix it, and the whole problem on all 20 places or 30 or 50 places where we put that code, that problem will be fixed. So what is the next thing to do right here? If we collide on the left side and the tag of the collided game object is player, what we need to check, if we are not stunned, then we will kill the player. So here, apply damage to player. Else, if we are in the stun mode, we are gonna push our game object. So we are gonna call my body velocity is going to be equal to new vector, so new vector 2. And for the x velocity, I'm going to say 15. For the y velocity, my body velocity dot y. So we're simply going to push that game object in the direction. If we touch it from the left side, we're going to push it to the right side, which is logic, because if I go back here, and not here, but here. So if I select the player and go here, if I touch or push the snail from the left side, that means the snail needs to go to the right side. It needs to go here. If I push it from the left, it needs to go, or from the right, excuse me, it needs to go here to the left side. We will see that in action right now. So what we're going to do for the right, if we have a right hit, which is the same thing, or just from the right side, we're going to test if our right hit dot collider dot game object dot tag is equal to my tags dot player tag. If we are not stunned, so if we are not stunned, we are going to do what? Kill the player. So we're going to apply damage to the player, same as we did here. And else, just copy the code. Else, if we are stunned, push the player in the negative side. So this is what we need to do. Let's test it out, and then I will explain it in short. When I hit the play button now, and when I go here and stun the snail, bam, the snail is stunned. Notice I'm going to push it from the left side. Bam, you see it goes to the left side. I have pushed it from my right side, or from the snail's right side. Let's do that again. If I go back here and stun the snail and push it now, this is my left side. So the left side of the player, but actually the left side of the snail. Notice now, when I push it, bam, it goes to the right side, which is, well, logic. When you push somebody from your left, he goes to the right. When you push it from your forward, he goes in his backwards. This is what we are doing here. And again, this is happening in the left collision, so left hit and right hit. If the tag of the collided game object is the player tag, and we are not in the stunned mode, then we are going to push the game object to his right side. Here, we are going to push the game object to the left side by simply applying velocity to his X. You see here, when we push him to the right, positive velocity. When we push him to the left, negative velocity. And let's test if this apply damage works by printing to the console. So here, if I go and type damage right, or actually damage left, copy this and paste it here, damage right. And if I go here in Unity, hit the play button, notice now in the console, if I touch the player, so bam, you see we are damaging our player from the left. Here we are damaging him from the right side. But if I, bam, stun him and I touch him, we are not damaging him because he is in the stun mode that we already did here. So if we land on top of the game object and that collision happened with the player, if we are not stunned, we are going to stun our snail. Of course, we are going to bounce off our player a little bit in the sky. We don't move anymore, and we stop moving by applying 0 velocity to the rigid body. We are playing now the stunned animation. Stunned is true to indicate that it's true, because here then we are testing if we are not stunned, we will apply damage. If we are, if it's true, we will push the game object in the appropriate side. So this is for the snail's movement. We are still not done because we're going to use the same script for the beetle. Until then, Fahir here from AwesomeTudes.com. We will continue in the next video.